Okay, good morning, everyone. Please, you can just help me by clicking good morning, or if you're able to hear me. Ah, that's wonderful. Since some of you have already started coming in, so we are going to start our class. As usual, please. My prayer is today we'll have a good, a nice network. So I will restart my class because it was cut the day or yesterday we couldn't learn properly. So I'm going to restart the class by reintroducing the sine function, but I'll be a bit fast from where we started from. So now I mentioned to say if we have a function, if we have y which is equal to sine inverse of x, then then um, then x will be equal to the sine of y. Now, because we already know how to differentiate the sine function of whichever kind of angle that it has, we already learned these concepts. This means that if we differentiate this x equal to sine of y with respect to y, so what we are going to have is so differentiating with respect to x, both sides, with respect to y, both sides, what you are going to get is the derivative with respect to x, or of x with respect to y. This is equal to the derivative with respect to y of the sine of y, which is going to give us the cosine of y. Now, this cosine of y is the one that we can also write as the square root of the cosine squared of y. Now, when we use the trigonometric identities, this is just equal to the square root of 1 minus the sine squared of y, when we use trigonometric identities. Then now, if you look at sine of y, if we go back, sine of y is equal to x. So where there is sine of y, we are going to put what? X. So this means the square root of 1 minus sine squared of 1, this is just equal to the square root of 1 minus x squared. So this is what we're going to have. So then, now the question is this the end of this derivative? Is this the end really of our derivative? Remember, what we want is to find the derivative of y with respect to x, the derivative of this inverse sine function with respect to x. But then what we did, we tried to manipulate this y, which is equal to sine inverse of x, into something that we can differentiate so easily. So what we did, we decided to write the whole of this equation in the form x equal to sine of y. After writing it, then we decided to do what? To differentiate this new equation with respect to y. Now, after doing that, then the second stage, I think this is where we ended yesterday. Then we have this disruption of power. So what you are saying is, so now here, what you are saying is, why this is coming in like this, what you are saying is, hence, so what you are saying is, the derivative of x with respect to y, this is just equal to the square root of 1 minus the square of x. Now, the question here is now, we need now to rewrite, I hope everyone is able to see, I hope everyone is able to follow what I'm doing. That's my belief. Please, if you're all able to follow, then you can tell me to say no, we're able to follow, just type. Now, okay, so after having that kind of a function, the issue here is, how can we solve? So in short, so now after we doing this, so what we're supposed to do now is to rewrite the whole of this in the form dy dx. However, if you look at dy dx, how can we write this in terms of dy dx? Or let me just explain it in a very simpler manner. If I explain this in a very simpler, however, okay, let me just explain it in this form. However, if you look at the derivative of y with respect to x, the derivative of y with respect to x is the same as 1 divided by, okay, the derivative of x with respect to y. So the derivative of y with respect to x is just equal to 1 divided by the derivative of x with respect to y. This will give us 1 divided by, but what is the derivative of x with respect to y? The derivative of x with respect to y is just the square root of 1 minus x squared. Then you are done. So what you have differentiated is the sine function with respect. So what you have differentiated is the function y, which is equal to sine inverse of x. Okay? So therefore, so if we want, you can add this statement. Therefore, the derivative with respect to x of the function y, which is just equal to the derivative with respect to x of sine inverse of x, this is equal to 1 divided by the square root of 1 minus the square of x. So then you are done with the construction of your solution. Please, if you have any questions, you can ask. If you have any questions, you can ask. Some of the concepts are in your notes. Please, you can ask questions if you have any. If you have any questions that you need me to clarify. Okay, I'll assume there's no. Okay, that's good since everyone is following. Okay, let's look at another scenario. So what we are saying is that if y is equal to sine of x, so maybe let me put this in general form. So this we should just remember it as a formula itself. So we are saying generally, if 1 y is equal to the sine inverse of x, then the derivative with respect to x of the sine inverse of x is equal to 1 over the square root of 1 minus x squared. 2, if y is equal to sine inverse, okay, of x divided by a, then the derivative with respect to x of this sine, the inverse sine of x over a, this is equal to 1 divided by the square root of a minus x squared. Oh, sorry, it's supposed to be a squared minus x squared. This was proved. Then we also have for cosine. So then I gave a general form. Now, if you look at this is x over a, and here we have sine inverse of x. Here we have sine inverse of x over a. So in general, in general form, if there are times, so remember that a is what? A constant. n is just a number. It's a number that you can think of any number, be it a fraction, be it a rational number, be it an irrational number, whichever kind of number that you can think of, all the numbers that you've learned. Now, I need to assure you that, for example, if we have y equal to the sine inverse of f of x, then depending on what x is, depending on what f of x is, then the derivative with respect to x of this sine inverse of f of x, depending on what this f of x is, you can get any general form. So what you're going to get is the derivative of f of x divided by the square root of 1 minus f of x. Sorry, this f of x squared. Please, you can verify that if you want, this thing will hold. This equation is going to hold. Okay. So then let's look at some examples that involves the derivative of trigonometric functions. Let's look at some other examples. Why I'm writing them like this, so that we can just have one thing at a go. We don't need to start reproving them and reconstructing them. That's why I'm writing all of them in this manner. Also, so I'm writing this is the third one. So let's write the fifth one. So if number 4, so if y is equal to the cosine of x over a, or this y is equal to the cosine of f of x, then the derivative with respect to x of the cosine of x over a is just equal to 1 divided by we have a squared minus x squared, which is the square root. Sorry, let me write this properly. So this is equal to 1 divided by the square root of a squared minus x squared. And also the derivative with respect to x of the cosine of f of x, this is just equal to the derivative of f of x divided by the square root of 1 minus f of x squared. Then we do the last one. I'm going to do the last one, which is the tangent. The last one, which is the tangent, which is number 5. Number 5. So if y is equal to the tan inverse of x, then we can prove this if you want. Then the derivative with respect to y of this function, the tangent inverse of x. So this is equal to a divided by a squared plus x squared. And if at all, and if y is equal to, so this, I'll put this as a, I can put this as b. If y is equal to the tan inverse of some function x, if y is equal to the tan inverse of some function x, Then what will happen is that then the derivative with respect to x of this tangent, tan inverse of this function f of x is just equal to the derivative of f of x divided by 1 plus the f of x squared. Okay, so these are the kind of functions that you'll be meeting: the tangent inverse, the cosine inverse, the sine inverse of. Then they are asking you now to find its derivatives. So this is what we'll be looking at as of today. Now, after having said this, let's look at some examples that involves the tangent function. I know in your notes, I've given you a lot of these concepts which are in your notes so that you can study and go through. But for now, we are going to concentrate on questions that involves the tan function, the inverse of the tan function, the inverse of the cosine function, the inverse of the and also the inverse of the sine function, and those are the ones that you're going to concentrate on and find their derivatives. Now let's look at question number 1. Example number 43 from your notes. Let's look at example number 43, which is in your notes. Every one of you has the notes already, which involves the differentiation. So if you look at that example, the example says differentiate y, which is equal to, okay, y which is equal to, this is example 43. The example says differentiate y, which is equal to the sine of what? Sine inverse of 7x squared. Y is equal to sine inverse of 7x squared. Y is equal to the sine inverse of 7x squared. Now, I would want to ask you, which method do you want us to use? Should we use the already given formulas, or should we start from the beginning? We go step by step and see how these concepts, how did they arrive at the final answer? Or do you just want me to go direct to the concept, to use the formulas which you have already structured? I think we have it. I think should be, it's saying it is f prime of x. Sorry, there's supposed to be an inverse here. It's saying the derivative of sine inverse of f of x is equal to the derivative of f of x divided by the square root of 1 minus the square of f of x. So it's either we use this method directly, or if you want, I have to restart by doing it that just like there we did when we just started with the sine function. Maybe if I do it in that manner, every one of you will follow. Okay, someone is saying let's do it step by step. Okay, that's wonderful. Okay, I hope everyone is going to follow. Okay, let's do it step by step. You know, when you learn step by step, these concepts will remain with you forever. But if I start using that formula which is given, once you forget that formula, it means you can't solve that question if it's given in any assignment or test or exam. So let's try to go. Okay, a lot of people are saying let's start from the beginning. That's wonderful. Okay, let's start from the beginning then. Let's look at the solution. Okay, let's look at the solution. Mhm. Yeah, we are freezing. Okay, generation. Okay, we're back. Okay. Okay. Okay, I hope everyone is able to see now again. Please just confirm with if you're able to see again. Please just confirm. Are we all able to see? Please don't start asking about the test. Let's concentrate on learning first. I will inform you later. Let's first concentrate on learning. This is not the time to start asking about what we cover. We are going to cover in test. Okay. Yeah, sorry for that. There was an internet disruption. Okay. So let's look at that question, which says that we wish to find the derivative of the sine inverse of 7x squared. This is the kind of a derivative that we wish to find. Now, the procedure for doing that is as follows. So our procedure will be as follows. So as you mentioned to say, I have to do each and every step which is involved. So I'll do likewise. So the first thing is the equation that we've been given is y, which is equal to sine inverse of 7x. Okay? Then if we rewrite this, then under trigonometry, if we can rewrite this, this is the same as we can say 7x is just equal to sine of what? Y. Okay. So 7x is just the same as is equal to sine y. Now, if 7x is equal to sine of y, now when you do this, when you reach this stage, remember you want to find dy dx. But since because you have decided to write this equation in this form, so you are supposed to differentiate. Oh, supposed to be squared here. So now we differentiate with respect to y. Don't differentiate with respect to x. Let's differentiate here now. You change the variable of differentiation. If you want to arrive at your answer so clearly, you change the variable. When you reach this stage, then you say now, then differentiate. You say differentiating with respect to y. What do we get? What are we going to have now? When we differentiate with respect to y, if we differentiate with respect to y, what we are going to get is okay. So if we differentiate with respect to y, what we are going to have is both sides. If we differentiate both sides of this equation with respect to y, what we are going to have is the derivative with respect to y of 7x squared, okay, of 7x squared, okay, then is equal to the derivative with respect to y of what? The sine of y. The derivative with respect to y of 7x squared is just equal to the derivative with respect to y of what? The function sine of y. Now, if you look at here, we are differentiating x squared with respect to y, which means we need to differentiate this implicitly. We are going to use the implicit method for differentiation. So this then, it will give us 7 times, okay, let me just write it. The derivative with respect to y of x squared, okay, is equal to now. The derivative with respect to y of sine y, it will give us the cosine of y. The issue here is we need to deal with the left-hand side. Okay, this is what we are going to deal with. It's the left-hand side that is that we are going to deal with in that form. Now, this will mean 7 times, okay, this means the derivative of x squared with respect to x times the derivative of x with respect to y will be cos. Why are we introducing this? Because on the left hand side, we are going to differentiate with respect to y implicitly. So, this is going to give us, what is this going to give us? It will give us 7, then the derivative of x squared with respect to x to give us 2x times the derivative of x with respect to y is equal to the cosine of y. Okay. From that, then we get, so what we're going to get now, after we do that, then when we do the multiplication, we are going to get the 14x times the derivative with respect to the derivative of x with respect to y, which is equal to the cosine of y. Okay. Now, before we do anything, but if you look at the cosine of y, the cosine of y, oh, in fact, I don't need to first write that. Maybe I need to go step by step. Okay, now, what do we want here? We need to produce the x dy. Making the x dy the subject of the formula, what this is going to give us is that the x over dy, this is equal to the cosine of y divided by the 14x. Isn't it? Then now, after having written that, so what you're supposed to do next is, now let's look at the cosine of y. Let's look at the cosine of y. Remember, so this is just the same as the square root of the cosine of y squared with respect over 14x. This is what you're going to have. Then this is just equal to the square root of what? 1 minus the sine squared of y. But when we started, but, okay, over 14x. Okay, but if you see, but then the sine of y is equal to x. When we started, what is sine of y? By the way, what is sine of y? Go back when I just started, I mentioned to say, so this is equal to the square root of 1 minus, where the sine squared of y, we are going to put 7x squared, everything squared over 14x. Why? Since the reason being, since 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 7x squared is equal to what? Sine of y. This is the reason that is making us have this situation. When we started, we said 7x squared is equal to sine of y. So when the sine squared of y, whenever the sine y, we substitute with 7x squared, so it will give us this. So what are you saying now? From this now, then we say, hence, okay. So what you have done is that thus, you say thus, what we get, we are saying the derivative with respect to x, the derivative of the function x with respect to y, this is equal to the square root of 1 minus, the square root, the square root of 1 minus 7x squared, everything you square them, divided by 14x. But have we been asked to find the derivative of x with respect to y, or we've been asked to find the derivative of y with respect to x? Let me say now, therefore, the derivative of y with respect to x, when you reciprocate this, you also reciprocate that, which is just equal to 1 over the derivative of x with respect to y, which is just equal to, but the derivative of x, which is just equal to 1 divided by the square root of 1 minus 7x squared divided by 14x. Okay, now 1 divided by this quotient, it's going to give us 14x divided by the square root of 1 minus, after you do some algebraic simplification, this is just in simplicity form, you have 14x in simplicity form, you are going to have 14x divided by the square root of 1 minus 49 x power 4. Then you're done. I hope we are following. I hope everyone is following. I hope everyone is following. So then you are done with the derivative of a given inverse trigonometric function. So you can either use the formula, or you can, if you can't remember the formula, then you just do these simpler steps. You just do these simpler steps and then you arrive at your answer. The other one is, we are being taught, show that if y is equal to cos inverse of x, then the derivative of y with respect to x is equal to the negative 1 over the square root of 1 minus x. So this is what this theorem is really, this is what example number 44 is trying to tell us. So it's saying that you have to show. So these are the questions that you're going to find anyway in an exam. Such kind of questions. They say show that this reduces to this. Then from there they'll ask you another question. Hence obtain the differential coefficient of y equal to cos inverse of 1 minus 2x squared is just the same as find the derivative of that function. It's just one and the same thing. All right. Let's look at some few concepts. That example, I'll look at that example. I think that will be the last example that I'm going to look at under derivative of inverse trigonometric functions. Any other, please, you just need to find time to go through them. Most of the examples, you already have them in your notes. Okay. All right. Let's look at that example. So the example 44, example number 44 from our notes. This example says, show that if we have a function y, equal to the cosine of x, then the inverse cosine of x, then the derivative with respect to x of this function y is just equal to negative 1 divided by the square root of 1 minus x squared. Then the next part is now asking us to say, using the idea in one, using the idea that you have found in one, find find dy dx if y now is just equal to the cosine of the inverse cosine of 1 minus 2x squared. So you are now using this concept to now differentiate part 2. So the part that you're going to work on really in details is the first one, but the second one you just substitute them there and then you find your final answer. Okay, now let's start. Let's start the solution. Okay, let's look at the solution to that question. Please follow me very well. So the approach will do it just like the way we proved that the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. It's just one and the same thing. The construction of the proof is just the same. Okay, let's look at the solution. So maybe I'll start. I'm going to start from this part of the board to construct the solution to the proof to this question. So now, I guess everyone should be able to see. Okay, so for y equal to the cosine inverse of x, it implies that x is equal to what? Cos y, isn't it? If y is equal to cos inverse of x, it means that x is equal to cos of the cosine of y. Then, differentiating both sides, then differentiating both sides of the equation x equal to the cosine of y by with respect to x, what do we get? We are going to get, if we differentiate both sides of this equation with respect to y, then what we are going to have is the expression. Okay, so what we are going to have is the expression, the derivative of y with respect to x. So the derivative of x, with respect to y, which is equal to the derivative of the cosine of y with respect to y. Now, the derivative of cos y is equal to what? The negative of sine y. And this one is just the same as the negative of the square root of the sine squared of y, which is just the same as the negative of that sine squared of y using the trigonometric identities. This is 1 minus the cosine squared of y. Here I'll say since cos squared of y plus sine squared of y is equal to 1. This is under trigonometric identities. Okay. This will give us, but what is cos y? What is cos y? Cos y is equal to x. So this means this is just the negative square root of 1 minus x squared. Why? Since x is equal to what? The cosine of y. Okay. Hence, what we have, hence the derivative with respect to y of the function x, this is equal to the square root of 1 minus x squared. This is what we are going to get. Okay. I hope everyone is able to see after switching off the lights. Please do tell me if you're able to see the board or it's faint. Ah, you can't see clearly. Okay, let me just switch on the lights. All right. Or I should use the black mark, I think. Okay. So now we are saying the derivative of x with respect to y is equal to the square root of 1 minus x squared. If that is the case, hence okay, therefore the derivative with respect to x of this y is equal to 1 divided by the derivative of x with respect to y, which will give us 1 divided by, oh, yes, negative, it will be, remember, so there's a negative here. Okay, so the derivative of y with respect to x is equal to 1 divided by the derivative of x with respect to y. But the derivative of x with respect to y is the negative of the square root of 1 minus x squared. Then we are done. So you have proved that the derivative of y with respect to x is equal to, where is the one coming from? Which one? Oh, the one which is on top. If you recall, that is reciprocating. Okay, let me put it in the simplest form. Let me show you how, if you know algebraically, maybe some of you are weak in terms of algebraic. Let me just put it in the simplest form. Right? Let's do this. Let's do this. We are aware. Oh, let me. I hope I can wrap the other part since everyone is having the notes already. I can wrap this other part, or let me just use the same one. Let's do this. Look at this. I need to put a line here so that I don't tamper with the solution top. So what we have is this. We have dy dx dy is equal to negative square root of what? 1 minus x squared. I hope you're able to see. I hope you're able to see. So this is what we have on the ground. This is an equation minus the square root of 1 minus x squared. This is an equation that we have, isn't it? So this is an equation that we have. And that one was, So this is the equation that we have. So what we're supposed to do is, you say, if we solving for, let's solve for dy. Our aim is to solve for what? Dy dx in this equation. So we want to solve for dy dx in this equation. So what can we do for us to solve for dy dx? This is the question that we are asking ourselves. So now, let's do it from the layman's point of view. Let's assume this is a ratio. So if you do the cross multiplication that you usually do, solving for dy dx, we have that. So what are we going to have? So if we do some cross multiplication, this is the same as the x. This means the x, I hope everyone is following, is equal to, we put it in brackets, the negative square root of 1 minus x squared dy. I guess everyone is following. Okay, now we are at this stage. If we divide each term by dx, if we divide both sides, but let's divide both sides by dx. Okay, let's divide both sides by dx. So we are going to have dx over dx is equal to negative square root of 1 minus x squared. Then dy, we also have dx. Okay, I guess everyone is following. Now, this and this will have 1. So what we are going to have is 1 is equal to negative square root of 1 minus x squared. Then we have dy dx. But then we want to solve for dy dx. So if we divide through each term by negative square root of 1 minus x squared, then this side we are only going to remain with dy dx. So if we divide through by that, we are going to have 1 divided by the negative of the square root. This will give us that. This means that. So, and then this will mean 1 divided by the negative square root of 1 minus x squared is equal to dy dx. This means of which dy dx is equal to negative 1 over the square root of 1 minus. So let me ask you, do you need, after you reach this stage, you start doing all this, or you just do that? So you can decide which one you are going to use, which you are comfortable with. I hope I've answered your questions. I hope I've answered the question of everyone, the doubt that you were having. Okay, let's go now to the next part of the question. The next part of the question let's look at the next part of the question. I think, which part can I wrap? I hope everyone you have followed what I was explaining. Okay, if everyone was following, then that's wonderful. So I'll wrap this part so that I can look at one more example, or part B of that example. So now let's go at part 2. Part 2 is saying that y is equal to what? The cosine 1 minus 2x squared. Okay. So using the idea that the derivative with respect, so this is the idea that you're going to use this idea. The derivative with respect to x of the cosine inverse of f of x is equal to, that is the formula that we're going to apply here, is equal to, it is the negative of f prime, the derivative of f of x divided by the square root of what? Divided by the square root of 1 minus the square of f of x sorry, I was supposed to write we use this. Now, if you check from what we are using, so if you look at y equal to cos 1 minus 2x, so we just say let f of x be equal to, let this f of x be equal to 1 minus 2x squared. So let f of x be equal to 1 minus 2x squared. Then f prime, the derivative of f of x, which is just the derivative with respect to x of what? 1 minus 2x squared. This is equal to what? Negative 4x. Hence, we now start substituting everything in this formula. This is what you're going to do. You now start substituting them into that formula, whatever you have found here. Hence, the derivative with respect to x, hence the derivative with respect to x of our function is what? Cosine inverse of 1 minus 2x squared is equal to the derivative of f of x. In this scenario, our f of x was equal to 1 minus 2x squared. The derivative of f of x is negative 4x. So we have negative 4x over, which is the negative, isn't it? The negative of negative 4x. So we have negative 4x over the square root. Sorry, let me just use one marker, color blue, over, so it will be the negative of negative 4x, everything divided by the square root of 1 minus, now, what is our f of x? Our f of x is 1 minus 2x squared, everything squared. Now, negative times negative positive, so we have 4x. If we expand this, the square of 1 minus 2x squared, what we are going to get is the square root of 1 minus, then when we expand this guy, we are going to get 1 minus 4x squared plus 4x to the power 4. So this is what we're going to get. Then when we simplify, once we simplify, so 1 minus 1, it will be 0. 1 minus negative, oh, so the negative of 4, it will be 4. So in general, what we are going to have is, 4x divided by the square root of 4x squared minus 4x power 4. Okay, then this is just the same as 4x divided by, we can factorize 4x, which is 4x squared, which is common. So this will give us the square root of 4x squared. In brackets, we can have x, we can have 1 minus x squared. Let's continue. We are now seeing the whole job of differentiation. When you reach this stage, you are done with the job, the entire job of differentiation. Now, what you are doing from this stage going down, you are just now bringing this answer to its simplest form. You are now bringing the answer to its simplest form. So the differentiation process ended from here. You differentiated, it came to this. Now, from this point going down up to where we are going to reach, we are just now simplifying. We are bringing our answer to its simplest form. All right. Now, so if you remember sines, when we did sines, this is the same as 4x divided by the square root of 4x times the square root of 1 minus x squared using sines. And this is going to give us 4x over, now, oh, this is x squared. The square root of 4 is 2. The square root of x squared is x. So we are going to have 2x times the square root of 1 minus the square of x. And then 2x into 2x1, 2x into 4x to give us a 2. So the final answer is going to be 2 over the square root 1 minus. That is your final answer after simplifying. Any questions? So I would ask you to handle these other questions. Unless if you have questions for me, then we can handle them. But if you don't have, please, you can tell me so that we can proceed. Maybe if I can only look at one example that involves trigonometric functions, one example that will involve trigonometric functions, and then from there, we'll call it the end of the class for sure. Please, let's respond if we have any questions for Mr. Matindi so that we can proceed, can move faster. Can you please respond so I can proceed? Oh, the eyes. Are people present or? Okay. Maybe I can proceed to the next part. Ah, that's wonderful. I'm seeing only one person responding. The rest are quiet. Okay, let's look at this. The question is saying, differentiate y equal to tan inverse of x over a with respect to x and show that the differential coefficient of y equal to the inverse tangent of 3x over 5 reduces to 15 over 9 plus 25x squared. So which is just the same criterion that we're using. So it's the same criterion that we are using. However, so it's the same criterion that you're going to use as well for all the questions. So let's look at, okay, cleaning my board. Okay, so now we are saying, the question is saying, that is example number example number 45 in your lecture notes is saying find the derivative of y equal to tan inverse of x divided by a, and show that. So they want you now to show that the derivative with respect to x, then you need to show that the derivative with respect to x of the inverse tangent of 3x over 5 is just equal to 15 divided by 9 plus 25x squared. This is what they want us to show. Okay, let's look at the solution. Let's look at the solution to this question. We start with the first one. We would say from y equal to the tangent, the inverse of the tangent of the inverse of the tangent of a over x we get we are going to have a situation that x over a is equal to what? X over a is equal to the tan of y. X over a is equal to the tan of y, which also we can rewrite as x is equal to a times the tan of y. Then now, if we differentiate, so if we differentiate this given function, so differentiating so now differentiating with respect to y, with respect differentiating with respect to y. When you differentiate with respect to y, this gives it to give us now we are differentiating x equal to a tan y with respect to y. We are going to get, that is what we mean, that is the derivative of x with respect to y, which is equal to the derivative with respect to y of a tan inverse, tan of y. But remember that a is a constant. So this is just the same as a times the derivative with respect to y of the tan of y. The derivative of the tangent function, it gives us what? Derivative of tan of y is sec squared of y. The derivative of tan y is sec squared of y. So the derivative of, I hope you're able to see. So the derivative of y is equal to sec Okay, yeah. So it will give us sec squared of y. Now, if you go to trigonometric identities, sec squared of y, so this will be a. If you go to trigonometric identities, sec squared of y is the same as 1. Sec squared of y is just equal to 1 plus the tan squared of y. 1 plus the tan squared of y. Now, because sec squared of y is equal to 1 plus the tan squared of y. But then what is tan squared of y? When we started, we said the tan squared of, oh, sorry. When we started, we said tan of y is equal to what? X over a. Tan of y is equal to x over a. So when there is tan of y, we substitute with x over a. So this is going to give us a plus a multiplied by 1 plus a, plus x over a, everything squared. Okay, so then, if this is the scenario, this means a, if we simplify, this is 1 plus x squared over a squared. I'm just doing the simplification for the sake of you to grasp the concepts, otherwise I would have just gone direct, but I don't want to leave anyone behind. Then, what does that mean? This means this is equal to a. If we do the simplification, it will be a squared plus x squared over a squared. When we multiply through by that a which is outside, what you are going to get is that a squared plus x squared over a. Hence, what are we trying to say? We are saying the derivative with respect to y of x is equal to a squared plus x squared over a. Okay. Now, from this, therefore, the derivative of y with respect to, if we solve for dy dx here, we are going to get this. Okay, so if we solve in this equation, dx dy equal to a squared plus x squared over a. If we solve for dy dx, what we're going to get is this, which will just give us a over a squared plus x squared. So the derivative of y with respect to x is equal to a over a squared plus x squared. So generally, I was supposed to write here dy dx. So this means what we are trying to say is that this means the derivative with respect to x of the tan inverse of x over a is just equal to n divided by s squared plus x squared. All right. The next step, I think you can okay, you can handle the next step, which just requires you to use the idea which you have already done. So the second part, I'll just leave it as an exercise. Uh, in so doing, I would say this is the end of differentiation. So I don't know if I can continue with, I can start integration. You can decide, please, you can just type there to say yes, you can start, or we can do this on Friday. Uh, Wednesday and Thursday, we are not learning because we'll be writing the tests. So if you say we can do it on Friday, we can start integration on Friday. Please, we can just give our views. Should we continue with integration, or we can just end here? Just type, we can even type in the group. Let's just type in our groups, the groups for mathematics. Okay, someone here is saying Friday. All right, so this is the end of this class. You can go through those. Okay, Friday. Okay, we can go through the notes, and then when we meet on Friday, we are going to look at integration, the basic properties of integration, some substitution methods of integration. So from there, then we are going to that's on Monday. The other day, or on Friday. Then next week we are going to look at some applications of integration and differentiation. Then that will be the end of the this calculus. Okay, thank you so much for your time. So we'll meet on Friday. Okay, there's someone who's saying Friday you have a test. So which day can we meet then? Apart from Friday, which day are you free? There is tomorrow, there is Wednesday. Please choose. Or from Wednesday, Thursday, Friday, you're having tests. So you are saying Wednesday, Thursday, Friday, you're having tests? Okay, let's chat in the group, then we can decide. Okay, have a nice day.